So today we're doing MMM31, definite integrals with U-substitution. We've done U-substitution before and we've done definite integrals, but we haven't done them together. And we've done U-substitution with indefinite integrals, and the difference is that when you have definite integrals, you have to apply a lower and upper limit to your integrand. So when you solve it with U-substitution, you can't apply these lower and upper limits, and the reason is that your lower and upper limits are defined in terms of x, and we're changing our integral. When we use substitution, we change the integral so that the function x is defined in terms of u, and these are defined in terms of x. So when we do definite integrals with u substitution, we have to use a technique called changing the limits, and when we use this technique, we can literally change the limits so that they're in terms of u, and now we can apply them to our solution. You can do it either way, without changing the limits and changing the limits, but when you do it without changing the limits, you have to do an extra step where you plug back in your original function, which was in terms of x, so that you can use the limits that were in terms of x. And that will become more clear when I do an example. So for the first example, this is our integral, and they have given us these limits. So from 0 to 2, solve this integral. Since we have an x squared plus 1, the whole thing to the power of 3, instead of FOILing it out, it would be easier to solve this integral with u substitution. So I'll let u equal x squared plus 1, and the reason I'm using this expression is that it'll allow me to cancel out the 2x. So if this is my u, then my d of x will be d of u over 2x, which is the derivative of this function. And since we're not changing the limits, I'll just immediately start solving this. So we have our integral with our limits 0 to 2, and then, well, actually, since we're using u substitution, these limits don't apply, so I'll just leave that blank. 2x, and then u to the power of 3, because u replaces this this expression, d of u over 2x. And so that cancels out perfectly with that, and this will equal the integral of u to the power of 3 d of u, which is the same as u to the power of 4 over 4. And now we can't apply our lower and upper limits from here. So we from here, 0 and 2, because we don't know what they are in terms of u. And so this is why we have to do an extra step where we plug back in our original expression. So u equals x squared plus 1, so I plug that back in, x squared plus 1 to the power of 4 over 4. And now we can apply our original lower and upper limits. So our lower limit was 0, and our upper limit was 2. And then using f of 2 minus f of 0 to solve our integral, this rule that we've learned in our previous packet, I'll do 2 squared, which is our upper limit, plus 1 to the power of 4 over 4, minus this whole expression using 0. So 0 squared, which is just 0 plus 1. So it'll be 1 to the power of 4 over 4. And for that you get 5 to the power of 4, right? 5 to the power of 4 over 4 minus 1/4, which should equal, that's the same as 25 squared, so that's 625 over 4 minus 1 over 4, and that equals 624 over 4. So that's your final answer. Now I'll solve it using the changing the limits technique. So again, we use u substitution. I'll write the same expression. d of x will equal du 2 of x. Now we have to change the limits. So to do that, first I'm going to write down my current limits that are in terms of x. So the lower limit I'll write as x subset L for x lower limit, and that is 0. And for upper limit, so u for upper, that's 2. Now to change the limit to be in terms of u, so u lower limit, you have to plug in your current limit in terms of x into the expression that you let u equal. So we have x squared plus 1, so we'll do 0 squared plus 1, which equals just 1, and then plug in 2, so u upper will be 2 squared plus 1, which is 5. So these are our upper and lower limits, and now I can use U-substitution to solve. And the difference is now I have my limits in terms of u. So I'll have 1 and 5, 2x times u to the power of 3, d of u over 2x. Again, these cancel out, and that'll equal 1 to 5 u to the power of 3 div u, which equals u to the power of 4 over 4. And now we can apply our limits, 1 through 5. And we don't have to plug back in this expression because we have our lower and upper limit in terms of u. So this will equal 5 to the power of 4 over 4 minus 1 to the power of 4 over 4. And that's the same as 624 over 4, which is the same as our other answer. And you should get the same answer. Alright, so next I'll do a problem that has a trigonometric function in it because that tends to be more difficult. So this is our integrand over here, and we have the function x sine pi minus x squared dx. So for this function, I'll set u equal to pi minus x squared, and hence our d of x will be d of u over pi is a constant, so we don't include that. It's just 0, and then you have to consider the negative, so it's going to be negative 2x. Now we're using the changing the limits technique. So our original lower limit is 0, and our new lower limit in terms of u will be, so pi minus 0 squared is just pi, and then our original upper limit was the square root of pi over 2, and our new upper limit, again in terms of u, will be pi minus our original upper limit over here, plug that into x, so the square root of pi over 2 whole squared. This square should cancel out with that kind of ugly square root right there, so that'll be equal to pi minus pi over 2, which is just pi over 2, or half of pi. So we have our new limits, and now we can go ahead and solve this and plug in these two as our limits. So we have pi as our lower limit, and pi over 2 as our upper limit. And we have x sine u d of u over negative 2x. So the negative 2 can come on the outside as half, and x will cancel out. So this will equal negative half pi over 2 pi sine u d of u. And that is equivalent to negative cosine u with pi and pi over 2. Now we have to plug in our limits and just solve. So it's very straightforward at this point. So negative cosine of, you take the upper limit first, pi over 2, which is the same as 90 degrees, minus the negative cosine of pi. And that whole expression multiplied by negative half. So negative cosine of 90 is 0, and so that's just going to be 0. And we have cosine of pi, which is 180. Cosine of pi is negative 1, but we have a negative in front of that, so it's going to be positive 1. So we have minus positive 1, and that whole thing times negative half. So if we do that, we get negative 1 times negative half, which is the same thing as half. So that is your answer to this integral when you use U-substitution and you use the changing the limits technique. Alright, so I'll do one more example for you guys. Instead of a straight up U-substitution, sometimes problems will give you these constraints, or they'll tell you these properties about your function f of x, and based on these you have to find out the answer to these other integrals. So for our problem here, we have the integrand of f of 2 of x from the limit 0 to 2. So I'll set u equal to 2 of x, and our d of x in this case should be d of u over 2. So we have d of u over 2, and now our original lower limit was, so x subset L for x lower limit equals 0, and our new lower limit in terms of u should be u times 2 times, 2 times 0, so that's just 0, and then you have our original upper limit, which was 2, and we'll convert that to our new limit, which should be 2 times 2, which is 4. So these are our new lower and upper limits, and now we can apply them to our integral. So we have now 0 and 4 times f of u, and d of u over 2. We can remove the 2 here and bring it on the outside of our integral, so it's going to be half 0 to 4 f of u. Now, we don't have a way to solve this unless we use this information over here. And what we can do is notice that your new upper and lower limits match one of these pieces of information they give us about this function. So the only other segment of this integrand that has the same lower and upper limits is this third piece of information they give us. So from 0 to 4, the integrand of f of x d of x is -8. Now, we can substitute this information into here because we have the same interval, we have the same lower and upper limits. And the reason we can do that is because we've substituted this function. U is another way of representing this function, so that's why it applies. So we can do half of, so this is equivalent to this, -8. So half of -8, and that is simply -4. That's all for U-substitution with integrals. The most important thing to remember is that you want to change your upper and lower limits, and remember to apply specifically your new limits to your integrand once you solve it using U-substitution. You don't want to accidentally apply your original lower and upper limits, which were in terms of x, and that's it.